Hey, Alan here. Welcome to another episode of Amazing Future. Today, seeing as it's 2020 and the world is going to hell and back, I thought I'd talk about something else which could potentially cause us a few problems. Well, that is if you call taking us back to the Stone Age a few problems. Let's get into it, shall we?
Shall we begin? Let's begin now.
Today I wanted to talk to you about space weather, starting with solar flares, or sunburps as the writer of this script likes to call them. They're pretty fast for a burp. A sunburp, solar flare, takes about 8 minutes to get from the sun to the Earth, so we don't get much warning about them. We've got satellites in orbit to try to detect space weather, but unfortunately we don't get much warning. Basically, a solar flare is an intense burst of radiation coming from the release of magnetic energy associated with sunspots. Yeah, that's basic. So, should we really be worried about these? Oh, wait, it's 2020. Solar flares are the largest explosive events in the solar system. So, I'm going with, yeah, we should be a little bit worried about them, seeing as Earth's not that far away from the sun. But we shouldn't be worried too much. Don't go move into a cave just yet. At least wait for the end of the video first, huh? Solar flares can cause degradation and at worst temporary blackouts in navigation and communication signals, and even damage to satellites. They are pretty bad, and those effects wouldn't be nice. But normally within a few hours they're back to normal again. Another aspect of space weather are CMEs, or coronal mass ejections. These travel a little slower, taking about 2 or 3 days to reach us, so luckily with a coronal mass ejection we do get some warning. CMEs can bump through and jostle the Earth's magnetic fields, creating currents that drive particles down towards the poles of the Earth. When these particles react with the oxygen and nitrogen in the atmosphere, they create what are known as the aurora borealis and the aurora australis, the northern and southern lights. CMEs, however, are a lot more dangerous, especially if you like your gadgets. Got a mobile phone in your pocket? Yeah, CME can ruin that totally. I nearly said something I shouldn't have done then. CMEs, they're not nice for technology or power grids or anything electrical really. The magnetic charge from a CME can affect a variety of technology. Sure, I just covered that. High frequency radio waves can be degraded or interrupted. GPS fixes can stray, which can cause problems if you're driving down a road and the GPS tells you to turn into a field. But now imagine you're flying an aeroplane with several hundred people on board, and it becomes a whole lot worse. The magnetic oscillations can also create electrical currents in power grids. That can cause overloads on electrical systems, blow transformers, especially if the energy companies are not prepared. Last time I did some research on this, I found only one company making the large transformers. And as they take quite a while to make, it would be pretty bad. I think the company was Siemens, some are based somewhere in Europe, and they're one of the only companies manufacturing huge transformers. According to a Lloyd's of London report carried out a few years ago, if a solar flare or CME knocked out a large number of transformers, it could cause economic damages of more than $2 trillion and cause disruptions lasting up to 2 years. So 2 years with no electricity, no communications, no internet, no satellite TV, no mobile phones. That wouldn't be good. But don't worry, not quite yet. That's the worst case scenario. Wait, it's 2020, isn't it? Anyway, a large CME can contain 1 billion tons of matter that can be accelerated several million miles an hour in a spectacular explosion. They would only affect the Earth if pointed directly at us. So, overall, the odds may forever be in your favour.
And may the odds be ever in your favour.
The solar material streams out through space, impacting any planet or spacecraft that gets in its way. CMEs are often associated with solar flares, but they can occur independently. Did you know the sun has seasons? It goes through high and low periods of activity, which repeat on an 11-year cycle, although some cycles have been observed to be as short as 9 or as long as 14 years. The solar cycle, or the seasons on the sun, are a good way to mark the changes in the sun. The two periods are known as solar minimum and solar maximum. During solar minimum, the sun may go for days with no visible sunspot activity at all, whereas during solar maximum, there may be several hundred sunspots per day. Oh, and during solar maximum, that's when the activity on the sun is at its highest and the effects of space weather here on Earth are at their most dangerous. The next solar maximum will strike no earlier than 2023 and no later than 2026, so hopefully 2020 isn't going to get too much worse. But wait, if this happens on a regular cycle, why haven't we been hit before by one of these solar flares or CMEs? We have. That's nice to know. Like all natural disasters, you can't predict a CME, like you can't predict an earthquake. You know, otherwise California wouldn't be panicking every 5 minutes when they get a slight tremor. Do they panic over there? I don't think they do. I think they're quite used to having tremors over there now. But yeah, you can't predict a CME or a solar flare. However, in 1972, NASA has revealed that a burst of radiation washed through space right between the Apollo 16 and 17 moon landing missions. They're so lucky they didn't have any astronauts in space at the time. Going back a bit further, on the morning of the 1st of September 1859, amateur astronomer Richard Carrington ascended into the observatory attached to his country estate just outside London. After cranking open the dome shutter, he pointed his brass telescope towards the sun and began to draw and record a cluster of enormous dark spots on the surface. Okay, I feel I need to stop right now and say,
Danger, Will Robinson! Danger! No, Will Robinson! Danger!
That if you own a telescope, a camera, binoculars, anything like that, do not go pointing them at the sun. This guy knew what he was doing. You and me, if we did that, we'd probably burn our retinas out and it wouldn't be a nice experience. We'd probably set something on fire. So yeah, don't be pointing things at the sun, kids, or even me. Back to the story. Suddenly, Carrington spotted what he described as two patches of intense bright white light erupting from the sunspots. 5 minutes later, the fireballs vanished, but within hours, their impacts would be felt across the globe. That night, telegraph communications around the world would begin to fail. There were reports of showers sparking from telegraph machines and wires, shocking operators and setting papers ablaze. All over the planet, colourful auroras illuminated the night skies, glowing so brightly that the birds began to chirp the morning chorus. Farmers got up, started their daily chores, thinking that the sun had risen. Some thought the end of the world was at hand, but Carrington's naked eye had spotted the true cause for the bizarre happenings: a massive solar flare with the energy of 10 billion atomic bombs. That's pretty big. The flare spewed electrified gas and subatomic particles towards the Earth, and the resulting geomagnetic storm, dubbed the Carrington event, was the largest on record to have struck the planet Earth. If that same event happened today, I wouldn't like to think of the consequences. It could blow transformers, as I said, on power grids. Electricity could go down all over the world for years. You imagine life with no electricity. We take it for granted, but it's turned us into a technologically thinking, forward-moving society. Without that, we are literally back to the ages of using fire. So not good, yeah. Anyway, on that note, if you liked the video, hit like, consider sharing it with your friends. If you want to see more amazing Futures videos, subscribe and ring the bell. I'm Alan, thanks for watching, bye bye for now.